In this video, we will go over composite functions, and this is the first problem, and this will be the second problem. So let's get started. So the first problem, let f of x is equal to x squared and gx is equal to 3x plus 5. And we want to find f parentheses gx. And so what we're essentially doing is f parentheses 3x plus 5. That's what gx is. Gx is 3x plus 5. So we say f parentheses 3x plus 5. So now we plug 3x plus 5 in for f. F is x squared. So simply 3x plus 5 squared. Now what we have is parentheses 3x plus 5 times 3x plus 5, and we're simply expanding it. So 3x times 3x is 9x squared. 3x times 5 is 15x. 3x times 5 is 15x. So that's 30x. 5 times 5 is 25. And so just to recap, so we have f parentheses 3x plus 5, and this is f parentheses x. So we are replacing x with 3x plus 5. And that's what we did for this problem. And now we will do the second problem. So we have g parentheses f of x. So we say g parentheses, instead of f of x, we say x squared, because f of x is x squared. So now we have g parentheses x squared. So x squared is now our x term. So instead of saying 3x plus 5, we say 3 parentheses x squared plus 5. We are replacing the value of this x with this value right here. And so the final answer would be 3x squared plus 5. And now for the second problem. Let f of x is equal to x squared minus 3 and gx is equal to 3x. Now in this problem, instead of having like gx, we have g2. And so what we do here is replace x with 2. So we have 3 times 2. And so we're putting in 3 times 2 for this right here. So f parentheses 3 times 2, which is f parentheses 6. And now we plug in 6 for our x for f of x. So x squared minus 3, instead 6 squared minus 3. So 6 squared is 36. 36 minus 3 is 33. And so this would be the final answer. And now we'll do this problem. G parentheses f2. So we plug in 2 for f of x, so f2. So 2 squared is 4. 4 minus 3 is 1. So now we have g1. G1. So we plug in 1 for x here. So 3 times 1 is 3. And so this right here would be the final answer. And that's all we need to do for composite functions.